today's video, here is a nice problem is coming from the craotian mathematical Olympiad. So here is the following setup for all x and y as a natural numbers. Satisfy this following equation. We get 3 to the x equals to the x is multiplied by y plus number 1. Okay, so remember we have x and y as a natural number. You guys, you can consider x, y as a natural number, include 0, up to you. So but in general we are taking the natural number as a whole number. Okay, it's not 0. Okay, so I'm not going to use 0 here as a solution. Is a solution is verifying this equation, but I'm not going to use it. Okay, you guys, you can give the try to problem previous solution. God was video when you come back to civil. Okay, notice here is a nice trick here in this problem. This problem is a little confused because of this product. Okay, why? So we are going to see that. Okay, now let's jump into solution. So I'm going to take obvious case x equals 1. So we get here 3, which equals 2 is multiplied by y plus number 1. Okay, so thus y equals 1. It's more simple. We have a first solution, x equals 1, y equals 1. Okay, let's move on to divide this one into two cases. When we have x is a odd and when we have x is a even, starting with the oddness. So if x is a odd, which means x is superior to 3, because already saw x equals 1 is a solution. Okay, so reducing this equation to the mod 4, I get this one 0, as we have x is superior to 3. I get here this one minus 1 to the x. It's more simple. Okay, so I get here minus 1 to the x is a congruent to 1 mod 4. This one is 0 because we have x is superior to 3. So if this one is a odd, this one is going to give us minus 1 is a congruent to 1 mod 4, which means it's impossible to have a solution for this equation due to the different reminders minus 1 and 1. Okay, now let's get rid of this one and move on to the second case when we have x is a even. If x is a even, let's set x equals to n. Okay, replacing that value of x into origin equation. So we'll have the following. I'll get 3 to the 2n, which equals 2. I'm not going to replace x. I'm going to tell you y in 1 second. I'm going to leave this x as it is multiplied by y plus number 1. Okay, because I don't need to replace x with anything here, because since I have number 1, I'm going to move it over to the left and make a difference of 2 squares, then factor out that on the form of the product. So I will have the following. I get 3 to the n minus 1 factor 3 to the n plus number 1, which equals 2 to the x is multiplied by y. Okay, here is not a good thing here. So usually when we have this product, always we have 2 to the x, which means we have 2 as a power here, which means each of the term is a power of 2. But the problem, we have this value of y, we don't know what it is. Okay, we don't know how to factor this one inside of this one, or even the parity of this one. Okay, so because the evenness cover this one, since we have a 2 as a power here, which means the left hand equation must be even. This one is even, this one is even, the right hand side of this equation even, but we don't know what y is going to be, odd or even. Okay, so now we need to change another method. We cannot solve this one as a power of 2 as it is. We cannot solve this equation on this form. Okay, so what to do? There is a nice lemma is called lifting exponent. Lifting exponent, I'm going to lifting exponent lemma. If you have these two numbers on, is going to be right on this form, e to the n minus b to the n. Okay, so applying this lemma on this one, and you have p is a prime. Okay, so which means p is going to divide this difference, a minus b. Okay, then GCD of p and a equals GCD of p and b, which equals 1. Okay, And then this lifting exponent is going to be written on this form: vp of x to the n minus y to the n. So we have n as a natural number, we have x and y as an integer. Satisfy this following equation. We get v of we get this lifting exponent of this difference x minus y plus vp of x plus vp of this exponent n. Okay, it's going to be in this form. But if we have p is even with this minus sign, if p equals 2 as an even prime, I'm going to replace this one here. v2 of x to the n minus y to the n is going to be written on the form of v2 of x minus y, this difference, plus the sum plus v of 2 of this exponent n as a natural number minus number 1. Okay, so I'm not going to prove this one because the proof is going to be longer, so I'm just giving you a general formula. Okay, we are going to use here this one. Why this one? Because I'm going to choose p equals 2 for our example, because I'm going to choose p as a prime equals 2 in our example. Okay, because I see here we have here 3 to the n minus 1 to the n. So as we said, p divides this difference, which means p is going to 2 is going to be 2. 2 divides 3 minus 1. Okay, so this is the appropriate prime which we can choose to solve our equation. Okay, now let's get rid of this one and move on to our proof. Now forget about this equation. I'm going back to the original equation. I'm going to apply this lifting exponent on this one. Okay, on the so as you said, x is even. So taking this equation, I get 3 to the x. Taking this number 1 to the left becomes minus number 1. Minus number 1 is going to be written on the form of x, because x in this case is a natural number, which equals 2 is to the x is multiplied by y. So the lefting exponent that we already saw, so is going to be written on this form, which means I'm going to choose p equals 2 as a prime, because this p divides this difference 3 minus number 1. Also GCD of 2 and 3, which equals GCD of this prime 2 and number 1, which equals number 1. Okay, so now I'm going to apply this lifting exponent on both sides of this equation, since we have equality here. So by apply it on the left hand side of this equation, I get v of 2 as lifting exponent 3 to the x minus y minus 1, which is raised to the x. As we saw before, this one is going to be written on the form of v2 of 3 minus 1, this difference, plus the sum of these two integers, plus the exponent x minus number 1. Okay, also I'm going to apply it on the right hand side of this equation, which equals v of 2 to the x is multiplied by y. So we are going to pick up only the exponent of this one. Okay, this is the meaning of this theorem. So 3 minus 1, which is 2, is going to be written on the form of 2 to the 1. So I get here v of 2 to the 1 plus v of 2. This is 4 becomes 2 to the 2 plus v of 2x minus number 1. I'm going to apply the rule of this one. So by separating this one by the product equals the sum of this one. So I get v of 2 to the 2x plus v of 2 to the y. Now let's analyze this one. So I get this one equals 1 because the exponent. This one equals 2 plus, I'm going to leave this one as it is because we don't know this one yet, minus number 1, which equals, I'm going to take the exponent of this one, which is x. Remember, always you have a prime here. Okay, the exponent, you have a prime to the exponent. We have already chosen prime equals 2 in this case. So, but the problem, we don't know the left-hand exponent of y. We don't know even the parity of y. Okay, so this one, usually if you have y is a, if we have number 2 as a prime, is a relative prime with y, this one is going to be 0. Okay, if you have a same exponent here, for example, you have a number 2 here, the exponent number 1, which is this one, is going to be number 1. Since we don't know the value of this one, is going to be always super equal to 0. Okay, so notice, note v of 2y is always super equal to 0. Okay, so cancelling out this one with this minus 1, so I'll be left with this one. So now this one is super equal to x, because we know v, because this one is positive, which means this one is going to be bigger or equal to x. So let's take this number to the right. So I get here v, the left-hand exponent of x is bigger or equal to x minus 2. I'm going to apply the left-hand exponent rule. This one, if I'm going to take this x out of this one, is going to be raised to the exponent as a base number 2, as a prime that we have chosen. Okay, so we get x as, okay, so we get x is super equal to 2 to the x minus 2. Now we are going to find a problem. If x equals 5, here, what is going to be happen here? This one, always the power of 2 is growing quickly than x. Okay, if I'm going to choose x equals 5, replace x with 5 here, I get 5. I get 5 minus 2 here, minus 2, which is 3. 2 to 3, which is 8. We get 5 is bigger than 8, which is impossible. Which means is a contradiction. It's impossible. Since it's impossible, which means x is going to belongs to this set, 2 and 4. Why? Because x is an even. Okay, so taking two cases here, x equals 2, replacing x with 2 here into the original equation, so I get 9 here, I get 4 here, 4 plus number 1, so which means 4y equals 8. In the other word, y equals 2. So we found the second solution. We found the second solution, x equals 2, corresponds with y equals 2. Then looking for the other solution, if x equals 4, replacing x with 4 here, I get 3 to the 4, which equals 2 to the 4 is multiplied by y plus number 1. So 3 to the 4 is 81, so which means 2 to the 4 is multiplied by y, which equals 80. Okay, 2 to the 4 it's 16, so 80 over 16 is going to give us 5. So we found y equals 5. So here is a third solution, x equals 4, corresponding with y equals 5. Okay, so the only three solutions that we found, excluding number 0 as a first solution. If you want to include that, but I recommend do not use natural number as a 0 as a solution set, because we have alternative set. We can say x and y as non-negative integers. Thank you for watching. I will see you next video. Bye.